Hi, we're just going to do a little bit of review before we get into more about the 6-3 and polynomials. So my first questions are just asking true or false. So number 3, is 3 a factor of 3,651? And so what we mentioned in class was that you could, in fact, use your calculator. I'm just going to clear this out, and you could just figure out 3,651. If I divide that by 3 and it comes out evenly, then yes, true, this is a factor. And so you could check the others and you would find out that yes, 4 is a factor and 6 is a factor, but for this one 7 is not a factor and 8 is a factor. So we could show it again like on our calculator. For example, the last one, 18,808. If I divide that by 8, it comes out evenly. And so we ask the question of, what does evenly really mean? So we're going to look at example or problem number 1 and problem number 4 or 5 really quickly to just look those over. So evenly means if I took, for example, 5,860 and I did it long division way, I said, okay, if I divide this, 4 goes into 5 once, so practicing our long division. Then I would subtract, so 5 minus 4 is 1. Then I'd bring down the 8, so 4 goes into 18 4 times. 4 times 4 is 16. I would subtract, so that's 2. So I have to bring down the 6. So 26, 4 goes into 26 6 times, so that's 24. I would subtract and I would get 2, and I'd bring down the 0 and I would say 4 goes into 25 times, and if I multiply that together I get 20, and I get a remainder of 0. And so when we say something is a factor and it divides evenly, it means there's a remainder of 0. And so all 3 of 1, 2, 3 and problem 5, if I did long division, or if I checked on my calculator, there would be a remainder of 0. Versus if I did a problem like number 4, where I had 2,563 divided by 7, 7 goes into 25 3 times, that's 21. Subtract, that's 4. Bring down the 6, 46. 7 goes into 46 6 times. 7, or 6 times 7 is 42. Subtract, that's 4. Bring down the 3. 7 goes into 43 6 times. That's 42. Subtract 1. I have a remainder of 1, and that means that is not a factor, and that's why we list it as false. So we need to know if things are factors, because then if they're factors, we can do what we just did in our last assignment, and we can find the zeros, we can find x-intercepts, and it just gives us a better picture of what the graph looks like. So what we're going to do next is we're going to figure out, are these factors of polynomials? So if I look at the first one, you should automatically see that if I look at both of those, x is a GCF, and GCF stands for greatest common factor, so of course it's a factor. Likewise here, x is a GCF, so again, of course it's a factor. So what does that mean again when we show it using division? What that means, if I do the first one, if I took my 4x cubed plus x and I divided by x, I would use my long division process. So I'd ask the question, x times what? So x times what gives me 4x cubed, and x times 4x squared. If I do 4x squared times x, I get 4x cubed. Now if I'm following my long division process, I would subtract these two. So if I subtract them, that's 0. We don't usually write the 0, and then you'd bring down the next term, which is a positive x. And you'd say, okay, x times what gives me x. Well, x times a positive 1. 1 times x is a positive x. You subtract those, and you're left with 0. So again, because the remainder is 0, we know that yes, x is a factor of 4x cubed plus x, and I get a quotient or an answer of 4x squared plus 1. And you could do the same process for number 2. In number 3, if I'm walking through that problem, it's not a GCF, but maybe it still is a factor. Maybe it's not the greatest common factor. So my setup would be x, and I'm dividing 7x cubed plus 3x plus 1, minus 1, excuse me, by x. So I ask myself the question, x times what gives me 7x cubed? X times 7x squared. So it'd be 7x cubed. Subtract that, that's 0. So I bring this one down. So 3x, and maybe I should make that red. 3x. So then I ask the question, x times what gives me 3x? Well, x times 3. So then I do 3 times x, which is 3x. I subtract. That's 0, and then I bring down the next one, which is a negative 1. And x times what gives me a negative 1? And there's nothing that I can multiply x by to give me a negative 1. That's a polynomial or a whole coefficient. So this is my remainder, and that's why this one is true, this one is true, but this one is false, because it's not giving me a remainder of 0. It's not a perfect factor. Okay, my last question. Is x minus 2 a factor? So I'm going to have to go through my division process again. Oops, sorry. So if I'm going to write it out, it would be x minus 2, and I'm dividing x cubed plus 7x squared plus 2x minus 40 by x minus 2. So I ask myself that question, x times what gives me x cubed? X squared. And so here's what happens. You have to multiply by this and get our x cubed, but you also have to multiply it by the negative 2. And x squared times negative 2 is negative 2x squared. And then you subtract. This would be 0, and now I have 7 minus a negative 2. Minus a negative 2 is really plus plus, so this is 9x squared plus 2x. I ask myself that question again. X times what gives me 9x squared? X times 9x. So 9x times x is 9x squared. 9x times negative 2 is negative 18x. And I'm subtracting. 9 minus 9 is 0. 2 minus a negative 18, minus minus. So that means I'm adding. So I have positive 20. And I'm dropping down my negative 40. So that's my question again. X times what gives me 20x? Well, x times 20. So 20 times x is 20x. 20 times negative 2 is negative 40. I'm left with a remainder of 0. So is this a factor since my remainder is 0? True. Yes, this is a factor. So what we're doing in this whole unit is we're trying to figure out, we just did that problem, we're trying to figure out if things are factors. So we're just practicing long division. So again, this is what I'm dividing by. I'm dividing the polynomial. And I'm going to answer the question, is it a factor? So you go through and you ask yourself, x times what gives me 2x cubed? 2x squared. So if I distribute it, that would be 2x cubed. I also have to do it to the 3. So that would be a plus 6x. and I'm subtracting. 2 minus 2 is 0. A negative 5 minus a 6. A negative 11. And bring down my negative 39x. Then I ask myself that question, x times what gives me negative 11x? Well, that would be negative 11. So negative 11 times x, negative 11 times 3. Oops, and this was a squared, so I missed my fault. These are supposed to be squareds. So this means there has to be an x up here. So that makes it 33x. Subtract 11x squared minus 11x squared is 0. Negative 39x minus negative 33. That would give me a negative 6x. Bring down the 18. X times what gives me 6x? Minus 6. So there's my negative 6. There's negative 18. My remainder is 0. So is this a factor? Yes, because the remainder is 0. So try a few more problems related to long division. Read the directions very carefully on the 6-3 worksheet because the directions are different for some of the problems, and you want to make sure to only do the problems that talk about long division or ask you to figure out if it's a factor or not.